Hey guys, and welcome to the joys of electricity. So with this video here, we're just going to show you how to use the multimeters and how to build a cell circuit. So the first thing, if you're trying to measure resistance of something, you need to measure it before you've done anything else, or you need to do it while it's in isolation. If you've got power going through the circuit, the multimeters can't measure the resistance, so you need to remember to do that off by itself. So I'll show you how to do that at the end, but that's just so you know. So how to build a circuit. You've got your, I'm using batteries in this case, but you've also got power supplies. So if the batteries aren't plugged in, you're not going to be getting much. So you can plug, if you want one if you want one battery or one cell in your circuit, you're going to plug it in across one cell. So here's one battery, here is one terminal. If you want to plug it in across both batteries, make sure you've got across two terminals there. So in this case here, I'm going to build a circuit where power goes through this point here, through the first resistor, through all of the resistors, through the light, and then that'll be it. That'll just be my circuit there. So I go from the power supply up through the banana cable into the first terminal. Power's going to run through here, and because I want to then close the circuit just like that, so power's come through, come around, this lead here will then join it back to the battery. So this should be a circuit right now. There's not very much light coming through. Okay, so there's power going through. If you see I move the resistances around, then I've changed my circuit, shortened it or made it larger. Okay, in this case, it's a pretty basic circuit. So if I now want to measure the current in the circuit, current needs to be measured in series, so it needs to be measured as part of the circuit. So what that means is you're going to need to move one of your leads. So this lead is annoying me, but we'll leave that one. I'm going to remove this lead here. So I've opened the circuit, so there's no power flowing now. So the circuit comes through here, through here. If I then want to measure current, it's going to have to go between the components and the battery. So I'm just going to leave that for a second. This is the multimeter I'm using here. Always use these grey multimeters for current. When you're going to plug that in, they have a ground terminal, which is this black one here, and then they have three other terminals here. So if you're measuring voltage or resistance, use this terminal here. It's got pretty pictures on it. If you're measuring current, always start with this one here with the amps. This one here is for milliamps, for microamps. Even if you think you've not got much in the way of current in your circuit, start with this one. In case you're wrong, and you've plugged it in this way, you run the risk of blowing the fuse in the multimeter. So always start from largest and work your way down to smallest. Same goes for measuring voltage as well. So in this case, we've got our circuit, comes through, banana lead, one lead into the ground. The other lead will go into measuring current, remember? So starts from the highest. Okay, on the screen we've got, on the dial, you've got, the ones on this side have a flat line on the top, and the ones on this side have a sort of wiggly line. So the difference is DC, AC. Since we're using batteries, we know this is going to be DC. We're measuring current, so we start from the largest measurement of current here, amps. As you can see, there's not much happening right now. So given that there's not much showing up on the screen, you can then work your way down into the lower levels of measurement, or the more accurate levels. So we can move this to the milliamps, microamps, and now we're getting a reading. If that didn't work, you could then switch the dial. But like I said, always work in that top-down approach. So now we have a circuit. We're measuring current as part of the circuit, so in series. I'm just going to reset that circuit for a second. So this is my original circuit here. If I now want to measure voltage, voltage is potential difference that's measured across a component in the circuit. So if I want to measure potential difference across let's say this resistor here. I'm going to plug each lead into across the existing circuit, so there's still power flowing through this, across one on either side of the thing I'm interested in. So in this case, that resistor there. Okay, just for variety, I'll use the other multimeter. So this multimeter is set up pretty much the exact same way as the other one. On-off button at the top here, a number of different terminals at the bottom. So this black one here is the common ground. One will always be plugged into there. And your other lead, if you're measuring current, we recommend to use the other one, the other multimeters for current, but if you do use this one, if you were to use this one, you'd start from the highest measurement and go down. And obviously this one over here is voltage. So because I'm measuring voltage, one will go into the common, oops, out of screen. One will go into the ground, and one will go into voltage. Now if you look on the screen here, the dial, you'll notice again, you've got obviously all the different measurements. There are a difference, same as with the other one, between AC and DC, so make sure you've got the right one selected. And then you should get a measurement for the voltage that's flowing through that particular component. So, turn that off. Okay, whenever you're not using something, please make sure it's turned off. As you'll notice, these two here are run off battery, so kindly turn them off when you're not using them. Okay, the same thing goes for the batteries. If you haven't got a circuit running at that point in time, make sure you've popped the batteries out like this. So you can actually cause a short circuit by leaving them in, which is not fun, so please don't. Okay, obviously if you're using the power supply rather than a battery, it's exactly the same. So before, our circuit looked like this across both batteries. Now, if I want to plug it into the power supply, it's exactly the same, one into red, one into black. Just so you know, you can turn this dial all you want, but while the circuit's not connected, there will be no current on the screen. The current can't flow if there's nowhere for it to flow, so there will be no current unless the circuit is connected, regardless of how much you fiddle this knob. Putting aside power supplies and batteries for the moment, if you want to measure resistance, like I said at the start, nothing can be plugged in to your circuit. Wrong way. Okay, that's sad. All right, so if I want to measure resistance across, let's go. That first one there. I'm going to plug a lead into either side of the component you're interested in, and then both of those leads, one will plug into the ground, and the other one will plug into the resistance terminal. And then you turn the dial until you have resistance on the screen. Now give it a second, and then it should come up with a measurement of the resistance through that particular component in the circuit. If you want to measure multiple things, so both of those, you just measure them together like that. Okay. If the multimeters don't appear to be working, check your circuit. That's usually the problem. If the circuit isn't completely closed, so if you have something that looks like, let's say I'm measuring voltage for a second. Have something that looks like this, it's not going to go because it's not connected. The other thing you need to do is make sure everything is connected and go from there. Okay. When you're about to go, do what I'm doing now. Disconnect everything, make sure the batteries are removed and everything is turned off. Cool.